Hello everyone, I'll be explaining in this video a currency exchange problem, and it was asked in starter 198 of codechef. So yeah, let me read out the problem. Chef currently has A1 gold coins and B1 silver coins with him. He can perform the following three type of transformations: pay one gold coin and receive five silver coins. This can be only done if he has at least one gold coin. That is obvious, right? If he has, let's say, one at least one gold coin, he can give one gold coin and take five silver coins, and pay five silver coins and receive one gold coin. This can only be done if he has at least five silver coins. That is obvious. Like if, let's say, he has five at least silver coins, so he may be giving to banker or some who makes transformation, and they'll give one gold coin. So one more transformation is that discard one gold coin and one silver coin. So he may discard one gold coin and silver gold, like he may lend to anybody. Basically, in the problem, what they have asked is it possible using these transformations for chef to end up with exactly A2 gold coins and B2 silver coins? So yeah, it is like they have given A gold coin and B gold coin. So doing these three transformations, would he able to make A2 gold coin and B2 silver coins is the question that they are asking. And discarding can only be done when he has at least one gold coin and one silver coin. And he cannot do in this way, like he'll be discarding one gold coin or he'll be discarding one silver coin. This can't be like, this is not valid. He will have to discard one gold coin and one silver coin, so this is valid. So yeah, I'll be explaining on the board, don't worry. First, let's take input. So we have integer t while t minus, this will take our faulty test cases. For every test case, I'll call a function solve, and its return type is void, it does not have any parameter. And for every test case, we have a1 b1 a2 b2, a1 b1 a2 b2. In a1 b1 a2 b2. So yeah, these are four things I'll be explaining you, don't worry. So we have, they have given four test cases. In first test case, 2121 is the a1 b1 a2 b2. Let's understand this. So a1 is 2, b1 is 1, and a2 is 2, b2 is again 1. So what they're saying is, initially a chef has two gold coins and one silver coin. Okay. So AB is not a good thing. Let me take this way. G1 is for gold and S1 is for silver. G2 is the gold 2 and S2 is the silver 2. Like this is initial gold and silver he has, and he wants to achieve this. So in this case, if you see, he has two gold coin and he wants to achieve two gold coin. That is there, true. And he has one silver coin. He wants to do one silver coin. That is true. So in this case, it is possible to achieve him. So this is one of the keys. So let's see. Yeah, output is yes, that they're saying 2115. Let's understand this. So what they're saying is, initially he have two gold coins and he wants to achieve one gold coin. So how he will be doing is, let's say he will be making transformation. So one gold coin he'll be giving and he'll be receiving five silver coins. So at the median stage, gold will be 1 and silver will be added by plus 5, because he had made one transformation. So silver will be 6. I think you guys got how to know. Like one gold coin is equivalent to uh, you know 5 silver coins. So that's why, like, one gold coin he have given, he have received 5, so he have got now 6 silver coins and one gold coin. So one thing, if you see, he wants to achieve one gold coin but 5 silver coins. And if you see here, he have one gold coin, that is true, but 5 silver coins he does not have. So if he wants to make, let's say, one transformation, like remove, discard one gold coin and one silver coin. So in this case, again, it will be 0 and silver 2 will be 5. But if you see, silver coins are achieved, but gold coin is not achieved. So no matter you do any operations, you will not be able to achieve from these two, gold coins and silver coins to this. So in this case, you will have to return no, right? So we have here no as. So let's try to take this one 3205 and let's try to understand how we will be solving this. It is a good problem. What was the question? 3205. Gold one and silver one. Gold 2 and silver 2. So basically he has 3 gold coins and 2 silver coins. He wants to achieve 0 gold coin. How he will do 0 gold coins? Like G1 will be 0 when he learns all the 3, he makes transformation. Like all the 3 gold coins he have given, for every gold coin he will be receiving 5 silver coins. So 15 silver coins will be added to S2. So now our S2 will be 15 plus 2, which is 17. This transformation I think you guys got to know. So this is the case now. And what, okay, gold coin is 0, that is achieved, but now silver coin he needs 5 but he has 17. So now here main thing we'll have to understand. So now if you try to remove silver coin by 6, silver coin S2 minus 6, what does this mean? Let me write first. So we have 11. What does this mean is that removing silver coin 6 mean is that, so you have 6 can be written as 1 plus 5, right? 1 plus 5 it can be written. So 6 means you have 1 gold coin and 1 silver coin and you have discarded these two. You have discarded these two. You understood, right, what I'm trying to say? So basically if I try to relate you in this way, like see, at one position we have this G1 as 0 and silver as 1. Why? Because 6 we have subtracted, which means we could discard 1 silver coin and 5 silver coin is equivalent to 1 gold coin. So which means basically we have discarded 1 gold coin and 1 silver coin. Now let's try to again discard. It's 2 minus 6, which means 11 minus 6, which is 5. So we have got our answer, like gold 1 is 0 only and silver 2 we have got 5, but again 6 we are subtracting. So if you try to reach this state, how would you do it? So I'll be telling basically how you should do it. Like again 6, I think you guys got to know this is how we are dealing with, but how do we visualize this again? So let me do it this way. So let's say you have G1 as 3 and silver 1 as 2 you have. Let's say now you discard 1 gold coin. So if you discard 1 gold coin and 1 silver coin, your G1 will be some intermediate step, it will be 2 and S1 will be 1, because both the silver and gold you have discarded. Now you want to discard one more. If you want to discard one more time, so your silver will be reduced to 0, gold will be 1. Since this is not what we need, you do one more transformation. You give gold coin and receive 5 silver coins. So in that case, gold will be 0 and silver will be 5. So making this transformation is equivalent to this one, what I've said right now. What I'll be doing is basically for any given gold and silver, so I will try to make this gold to be equivalent to the final what they want. Okay, so I want to make 0. When you have 3 and you want to make 0, so 3 gold coins will making transformation. So in that case 3 into 5, because for every gold coin 5 is the silver coin that will be getting. So 15 coins you have got, so you have added 15. So 17 silver coins you have. Now since this is not equal to S2 what they want, since gold 1 will be equal to gold 2, since we have done the operation, but in order to make this gold 2, you will be subtracting 6 every time. So subtracting 6 means is that we are discarding 1 gold coin and 5 silver coin. So sorry, we are discarding 6 means you have 5 silver coins plus 1 silver coin, and this 5 silver coin is equivalent to 1 gold coin. So which means you are discarding 1 gold coin and 1 silver coin. So that's why So now if you try to make subtract 6 this is not a valid thing. I mean, this will take time. So how do you subtract? So see, you have s1 plus 6 times k you want to make to s2. You understand that this one what I'm trying to say? So what I'm trying to say is that since s1 is bigger, right? You have understood, like since gold we have made zero, equal, so silver has to be increased because we are making transformation. So silver will be more. So in that case we are writing it will be 6 times k plus silver 2, something like this equation will come into picture, right? uh, so now you make this equation divided by 6 is equal to k. So basically what you will be trying to do is that s1 minus s2 modulo 6, it should give you 0. If that is not giving, which means k is not a whole number, you need to get k as a whole number, right? So this equation I'll be using in the you know code. So don't worry, one more time I'll be explaining you. So one case you have understood wherein gold was greater than the final gold. Initial gold was greater, final gold was lesser. So there will be cases wherein lesser gold will be having and more gold at the end we require. So when we have more gold and lesser gold in the destination, so in that case our s1 definitely will increase, and it will increase, and we will be checking if this s2, sorry s1 what we have after increasing is lesser than s2. So in that case we can't achieve this, right? Like we have achieved gold but we will not be achieving silver. So I'll be telling you, don't worry. So, and yeah, let's try to take other example. In this case we were able to do transformation, so we will be returning yes. We have one more case 2945. 2945. So if you see in this case gold coin we have less gold coin, right? So how you will be doing equivalent to this one 4. If you take 10 silver coins, so that will be equivalent to 2 gold coin, and 2 plus 2 will be 4. So what you will be doing is your silver coin whatever you have, from that you are subtracting s1 minus how many you need. It will be g2 minus g1. Why g2 minus g1? Because g2 is bigger in this case. So g2 minus g1 will give you 2 into 5 if you do. So basically 5 silver coins are needed to make gold coin. So your s1 was 2. So sorry, s1 was 9 not 2. So which means your s1 is now minus 1, which means you don't have any silver coin, but your gold coin is now 4. Why your gold coin is 4? Because you have taken 10 silver coins and made into 2 gold coins, and which was equivalent to g2. So g1 is equals to g2 equals to 4 now, but your silver coin went to minus 1. In making gold coin equivalent, your silver coin went negative, which means in this case you are not able to do this thing. You will not be able to do all the three transform. I mean, you will not be able to actually achieve this state wherein your final gold is 4 and silver is 5. So I think you guys got to know. So how do, like how will I'll be solving this is that I think from the examples you got to know there are two cases where gold 1 is greater than gold 2, greater than or equal to also. Let me take, when gold 1 is greater than or equals to gold 2, in that case you will be doing what, uh, gold to silver conversion, right? So your silver coin which like you have in 1 and s1, that will be increased by g1 minus g2 into 5. Okay, which means now your gold coins are equal but silver coin has increased to this much. Now you will be checking if silver coin 1 is equivalent to silver coin 2, you'll be outputting yes, because gold coins are equivalent. Now silver coin is also equivalent, so you'll be outputting yes. Else what you'll be doing is you'll be checking if this silver coin what you have, that should be greater than 0, right? Because if it is in negative, so in that case your answer is not true. It should be greater than 0. And one case is that you'll be checking s1 minus s2 modulo 6, that should be equals to 0. I think you guys understood why I'm doing this one. So why s1 minus s2? It may happen that like one more condition I'm missing. One more condition will be s1 should be greater than s2, because since gold coins are equal now, and s2 has to be greater than 0, because if it is lesser than 0, if it was equal to 0, it was in this case handled. So like if s2 was also 0, s1 also 0, we would have printed yes. But let's say we have s1 more and s2 some value, so this is the case we are dealing with. That is fine. Now why s2 should be greater than s1? uh, when s1 is less than s2, so in that case your answer will be no only, so that will go into one more else condition. But when your this is the case, like when s1 is greater than s2, so in that case you could remove 6 silver coins to make discard of one gold coin and one silver coin. And this is again and when you have s1 more than s2, so in that case the remaining, I mean s1 minus s2, whatever remaining silver coins you have, that should be exactly divisible by 6 in order to make discard transformation. So I think you guys got. And this was one of the if condition. Let me deal with one more. We'll go to else, because when a1 which is g1 greater than equals to g2 was it, this was we have dealt it. When else is there, which means in this case g1 is less than g2. When g1 is less than g2, so this is the case you could think of. You want to make g1 equals to g2, so in that case you will be taking silver coins and making 2 gold coin. So your silver coin whatever you have, that will be subtracted by uh, since g2 is bigger, right? So g2 minus g1 into 5. I think you're getting right. So which I told you already, like your silver coin will be decreased by number of difference in gold coin into 5, which is you want to make from 2 to 4, so you'll be requiring 10 gold coins. So if you try to put in this, it will be 4 minus 2 is 2 into 5 10. So you'll be subtracting this thing silver coin from the current silver coins. And now you'll have to check if uh, this silver coin is equivalent to this required silver coin. So in that case you'll have to print yes. Else if you'll have to check this silver coin has to be greater than 0. And now again we'll have to check s1 should be greater than s2. Why s1 should be greater than s2? Because like we have done gold equivalent by doing this operation. By doing this operation we have made gold equivalent. So if silver coin were equivalent to s2, so we could have printed yes. But now two cases arise. If it is not equal, silver coin has to be lesser than s1, so in that case our answer else case will be there, so we'll have to print no, because gold coins are equal but silver coins are not making equal. But one more case is that silver coin should be greater than s2, right? So this is the case where when we are checking, can we discard gold coins and silver coins. So for that again we'll be checking s1 minus s2 modulo 6 is equals to 0 or not. So if it is equivalent to 0, so we'll have to return yes. So I think you guys got to know how do we solve this, and you got to know what is the technique behind solving this problem. So let me try to code it up here. So Let me take the variables what we are using on the board: G1 silver 1, G2 silver 2, and let me take here also the same way: gold 1 silver 1, gold 2 silver 2. So we will be checking if initial gold what we have, that is greater than equals to gold 2. So so in that case what you will be doing, you will be checking your silver coins will be increased by G1 minus G2 star 5, right? Since gold coins are equal, now silver coin is increased. Now you will be checking if silver coin is equal to S2, final silver coin. So in that case you will be outputting yes. Else if you will be checking like S2 has to, S1 has to be greater than 0, and S1 has to be greater than S2, and S1 minus S2 modulo 6 equals to 0, which means your silver coins are greater than 0 and it is greater than final, and whatever extra we have, that is exactly divisible by 6, which means we can use discard operation. So why 6? I have told you multiple times, let me tell you one more time. 5 silver coins will make you 1 gold coin, and 1 silver coin is 1. So in the question they have said like you can discard 1 gold coin and 1 silver coin, so it is equivalent to discarding 6 silver coins. So if this is the case, so definitely we can make goal G1 equal to G2 and S1 equals to S2, so we'll have to print yes, else it is not possible, so we'll have to print no. Now when we are in else condition, which means initial gold one is lesser than the G2, so in that case your silver coin will be making into gold coin. Basically 5 silver coins will be taking and making into 1 gold coin. So that is done by basically G1 minus G2, sorry, G2 minus G1 star 5. And we'll be checking again if silver 1 is equal to silver 2, because golds are no equal, silver you will have to check it. So if both are equal, which means you'll have to print yes, else if again you will be checking this silver 1, it should be greater than silver 0, and S1 should be greater than S2, and again S1 minus S2 modulo 6, it should be greater than this modulo has to be 0, then you will be printing yes. Why? Again let me repeat one more time. So what do by this is that now here gold coins are equal. You have made silver coin into gold coin, so gold coins are equal. Now silver coin we have, if that silver coin whatever we have is equal to the destination final silver coin, so in that case we'll be printing yes. If it is not, then again two cases will arrive, like silver coin is less than S2 or silver coin is greater than S2. When silver coin is less than S2, so in that case obviously you cannot have answer, so you'll go to else condition and you'll have to print no. But when your silver coin is greater than S2, so we have this condition here, so in that case we'll have to check like whatever final silver coin you want and whatever you have, if the subtraction of that is remaining one, if those are multiple of 6, so in that case you will be using discard operation, so you'll have to print yes. And why S1 greater than 0 is that it may happen that S1 goes beyond below 0, so in that case also it is not possible, so which I showed on the board, third case. So yeah, let's try to run the code now. We should be getting yes no, we're getting it. Let's try to submit the code. Yeah, it got accepted, and I think this was a interesting problem, and if you guys have understood it, so do let me know in the comments as well, like you have understood. So like if you say me yes no, it will be motivate me to explain these kind of problems, and basically I am explaining you in an easy way. You may find some of the videos in YouTube. So yeah, this is I think one of the easiest way, and you have understood in depth how did I solve it. If you did not understand, you may re-watch this video and you will definitely get it. And yeah, thank you guys for watching the video.